Alright, we got another wonderful problem. So this one we're dealing with vectors. We're given vectors in various coordinates, either the rectangular, x and y, or the polar, which is that r and theta. And we want to be able to jump back and forth between them, being able to express one in terms of the other coordinates. Because some problems, certain coordinates will be easier than others. So we have to be really comfortable doing them. Okay, so part A says we want to convert the vector of A equals 1, 1 to polar coordinates r and theta. So getting the r is easy enough. It'll be a square root of 1 squared plus 1 squared equals the square root of 2. Now for the theta, you got to be a little careful. So how I always like to do it is I always like to draw it. Okay, so here's the point we're looking at. It's at 1, 1. Here's the angle I want. So here's that triangle there. Here's theta. This is of length 1, and this is of length 1. So I know the tangent of theta equals 1 over 1. Therefore, theta equals tan to the negative 1 of 1, and you will get 45 degrees. So this is our theta. Straightforward enough. Okay, now let's look at part B. Part B, we want to convert the vector. We should have vector symbols. Negative 3, 1. So r is easy enough. Negative 3 squared plus 1 squared. This is the Pythagorean theorem. That's what we're really using here. A squared plus b squared equals c squared. But now let's be careful with our theta, right? So let's see where this point is. Okay, so the angle I really want is this angle right here. But in order to do that, I'm going to find this smaller angle first. The reason being, if you are not careful using tangent, you can get the wrong answer pretty easily. So I know this is 90 degrees. So if I can just find this tiny angle, then we're in business. So I always like to redraw the triangle. So here's this intermediary angle that I'm looking for. I'm going to call it phi. And opposite of phi is the x length, right? This is of length 3 right here. So I'm going to put a 3 right here. Adjacent to the triangle, adjacent to this angle, is my y length. So I'm going to have a 1 right here. So then I can write that phi equals the tangent inverse of the opposite over the adjacent. And that will get me 3. That'll get me 71 degrees. And that kind of makes sense. This negative 3, this is a bad picture. It should be lower over here. So then my theta equals 90 plus phi equals 161 degrees. Okay. So a lot of times people will use this formula. This tends to get people in trouble. It doesn't always work. There's problems depending on what quadrant you're in. So I can't keep it straight. It's too complicated for me. So how I do it is I always redraw this triangle, make this triangle right here, find this intermediary angle, and then make it go from the x-axis. Right? Because here's my theta is this blue one. All right, so now for part C, we want to go from polar to Cartesian coordinates. And this way is a lot easier. There's really nothing to think about. So for the first one, we get r equals 4. Well, they actually told us that this was the magnitude of c, but whatever. And we're told that theta equals 80 degrees. So this formula will always work. X equals r cosine of theta. Y equals r sine of theta. As long as theta is from the x-axis. Right? So theta needs to be from that positive x-axis. It's a terrible drawing, but you get the idea. So plugging in numbers here, I'm going to get 4 times the cosine of 80, and I'll get 4 times the sine of 80. You can plug that into your calculator and see what that would be. So then part D will be largely the same. D, we're told that the magnitude of D is 10. And we're told that theta equals 160. So x equals 10 cosine of 160. Y, I'll put some parentheses, equals 10 times the sine of 160. Why don't we plug in some numbers? So this one, this angle is going to be in the second quadrant, right? Because it's less than 190 degrees, but greater than 90 degrees. So I expect this should come out negative, and this should come out positive, right? Because here's that second quadrant right up here. So sure enough, I'll get 10 times the cosine of 60, or 10 times the cosine of 160 equals negative 9.4. I'll get 10 times the sine of 160 equals 3.42. Okay, and this angle was pretty close to 180 degrees, so I would expect the x, the value of this x to be greater than the value of this y. Okay. But that's how we do everything. So going from polar to Cartesian is a lot easier, a lot less room for mistakes. But this theta, I see this theta get students all the time. So when you're doing this theta, take it nice and slow, and really think about what you're doing.